Hello, everyone. Welcome. Thank you for joining. So today we're going to have a dev meeting that will be focused a little bit on safety features in our ecosystem. It's going to be divided into two parts. Christopher is going to have a short presentation about safety features now, safety features in the future. Maybe we can have a discussion and then maybe a more general discussion for everything that can pop into your mind. Now, if everyone is ready, and mainly Christopher, maybe we can start.
Yeah. Let's see if I can manage. No, I can't. How do I cast this? I thought I could do it like this. Where? Can you see something? Share. There's a lot of clickety clicking.
Yeah.
Can you see it now?
Yep.
Fantastic. So, yes, the supervisor. We have had a module in the Crazyflie. It's called the supervisor for some time. I don't know, a year or two, but it's been pretty. It's not been doing a lot of stuff, mainly just keeping track of if we're flying or not. So I mean, this is going to be a pretty quick presentation, but what we wanted to do now was to improve the safety for larger platforms, brushless platforms like the Bolt and Big Quad Deck. And when you have a larger platform, it's a good idea to have a little bit more safety features, like so it doesn't fly away when you don't want it to fly, or maybe if it goes bananas, it should maybe stop and things like this. And there has been we have a bunch of features in the firmware already, but they are sort of spread a little bit all over the place, and we wanted to make this a little bit more centralized so it's easy to find where this handling is. And we wanted to make the arming a little bit more structured. We want to, at least in the future, make it possible to do slightly more controlled emergency landing. So instead of just falling down, maybe we could do a soft fall, for instance. So we spin the motors a bit, but a little bit slower. So the drone falls down, but it falls down a little bit more gracefully. It would also make it possible, or what we want to make possible is that if we still have good position information from a positioning system, then we could do some sort of even more controlled landing, maybe go back to some sort of starting point or whatever. So those were the goals. And this is something we've been working on the last 2 weeks. Like I said, the current situation is that this code is spread a little bit all over the place. It has been added at various times through the years. So maybe there is a timeout on some sort of CRTP level to check that we get set points, and if we don't get set points for a while, then we turn off the motors. And maybe there is some functionality in high level commander doing something similar, and so on. So it's a little bit all over. It's hard to find, it's hard to understand how it works. There might be some also conflicts in the implementations. So maybe two safety features are sort of competing. So what we wanted to do was to move all of this into the supervisor module. And like I said, the supervisor module has been around for a while, but it is currently very thin and is not doing a lot. So this work has been about moving all of the features we have now into the supervisor. and also create a structure that will be make it possible to extend this into softer landings and other nice features for the future. So in the pull request 1272 in the firmware, we have a start. It's not completely finished yet, or the supervisors maybe is pretty finished, but we want to add the arming functionality as well. But this puts everything in one place. So the supervisor is going to monitor the system, and it hooks into the stabilizer loop where it can override data at different levels. So it can tell the high-level commander, for instance, to stop generating a trajectory. It can override a set point. So maybe we get a set point from the, I know, a gamepad or something over radio. But if the supervisor thinks that something is going wrong, it can override this set point and put its own data into it. And finally, at the lowest level, there is a hook at the pretty much the motor control level. So if everything is really bad, we just turn off the motors. The supervisor is implemented as a state machine where we have a bunch of states. These states could be something like flying, for instance, or pre-flight checks, or we're going to look at those a little bit later. So in each state describes a unique situation that the drone can be in, so to speak. We have a bunch of input data that we look at, and this is, for instance, if we are armed or if we're tumbled, if we're flying, and things like this. And this set of input data is used to figure out if we should transition from one state to another. And we have tried to make this as condensed and clear as possible. So there is pretty much a list for each state we can be in. There is a very clear set of what conditions that needs to be met to transition into another state. And we have tried to get rid of all logic in terms of if-else cases and things like this to avoid the possibility of ambiguity in the implementation. So it's just a pretty much a bit field where each bit represents one of the conditions, and if these are met, we transition into the next state. On the state transition, it's possible to add action. So maybe we need to do something. We go from one state to another. Maybe we need to turn off the motors or whatever might be needed. We don't use this that much yet, but it will be useful in the future, I think. And this PR implements this supervisor, the state machine, and essentially re-implements what is already in the firmware. So it is more or less working the same way as before. It's not completely true, but it's pretty close. So I think that most people will not see any difference. And finally, just a graph or illustration of the states that we currently have. So first we have a pre-flight checks not passed. This means that this is pretty much where we start. This is where we check if all pre-flight conditions are fulfilled. So this is, for instance, that the USB cable must not be connected, the drone must not be upside down, and things like this. If all these conditions are met, then we transition into the next state, which is pre-flight checks passed. If we also, if we are armed, a normal Crazyflie, it's going to be automatically armed, but a bolt, for instance, is going to need some manual steps here for arming. Then we transition into ready to fly. And at this point, we will enable the motors or allow the motors to spin. Motors are only they're only allowed to spin in ready to fly and flying. So in ready to fly, we are ready to fly. And when we start to move around, we transition into the flying state, fly a bit, and when we are back on the ground, we go into the landed state, automatically transitions to the reset state, and then goes back to pre-flight checks, not passed. So for a normal Crazyflie, the standard firmware, the pre-flight checks will usually pass if you just put it on the ground. The arming is going to be true by default, so it pretty much directly goes into ready to fly. So if you have a gamepad and you fly around a bit, you're going to go into flying, and when you land, after a timeout, I think it was a couple of seconds, it goes back to landed, reset, pre-flight checks, and then automatically goes to ready to fly. So for manual flight, everything is going to behave pretty much as before. Yes. We also have two exception states, or the warning level out. This is something that used to be implemented in the high-level commander. So if we do not get any set points for a while, the drone levels out. And if we still don't get any set points, we enter the exception free fall state, which means we just turn off the motors and fall down pretty much. And from here we go to the lock state, where the drone must be rebooted to be possible to use again. And it's still alive, but motors will not spin. Yes, this is pretty much all I intended to say about the supervisor. I don't know, are there any questions or comments or anything else? Only complete silence.
You can also ask question in the chat. There's a small feature if you want to write.
Does it sound like a good idea? The plan is that we will be able to add more states here in this. So maybe we have a state which is somewhere in between the level out and free fall. So we have a controlled fall or soft fall maybe. So hopefully this framework will allow for extensions.
Yeah, can you hear me?
Yep.
Yeah.
Good. Yeah, I just wanted to say I'm glad that you're developing this framework, because I think it was missing a bit in the firmware, and handling some of these situations will be much easier, as at least when there is a framework for that already. For example, what we personally struggle with quite a bit is the tumble check. So basically, if you take a Crazyflie, you put it upside down, it locks, and you cannot unlock it anymore. So, or at least it's not very easy. So the easiest is to reboot it. But yeah, for example, when you fly manually, that might not be so handy. One example is when you give a demo and you might like walk around with the drone before you actually start flying and it locks. So I think here it's already much clearer, like where that this can actually be reset, and there's a for that. So for now it all seems great.
Yeah, very good, very good. Yeah, it's much easier now to. So this is actually one of the changes I did compared to the current version. That if we are in pre-flight checks and we are tumbled, then we stay in pre-flight checks. I mean, it doesn't pass. But if you put it down, it's not tumble anymore. So then you can fly. So this problem is gone. The one you mentioned that you accidentally put it upside down when you walk to the floor. I think if you're flying in the tumbles, it's still, then we end up in the locked state. But that would be easy to fix as well. For a while I had it so when you tumble it reset and came back to. So, but like you say, it's much easier to modify the behavior now, which is nice. Yeah, we got in the comments.
Yeah, someone that asked if it might be good to add geofencing.
Yes, and this is typically one of the features that would be easy to implement, hopefully. And that would, I mean, definitely be interesting for shows maybe, or similar situations when you have to stay within some sort of flying space. So yeah, this is one of the things we are hoping to add somewhere in the future.
Maybe I wasn't following closely enough, but so for example, when we go to the warning level out state, what is the trigger there?
This is if we don't get set points for half a second, I think.
Oh.
So this could be if you're flying manually and your radio dies or whatever, you're out of range maybe, or if you're flying, I guess it could be a script as well that is not pushing set points anymore for some reason.
Mm-hmm. Yeah, I'm thinking about this in connection with a positioning system that might, maybe just give low quality readings, and then maybe you prefer to just wait till they get better again. So this could also be a trigger for this.
Definitely, yeah. Most likely, I think there's going to be more states, like I mentioned, a soft fall, for instance, or maybe a go back to base similar thingy. If the supervisor sees that the positioning is still stable, but something else is wrong, I don't know what that could be. Then we could, I mean, at least maybe land straight down, or maybe go to some predefined spot. So I think there can be many different or more different states in the future. I mean, like geofencing, for instance, that's not really, if we still have a strong or good positioning, then it's, I mean, it's not an exceptional state probably. It's more a state that needs to be handled, and if we still have positioning, we can do something clever and nicer than falling down and breaking apart. Do you mute that?
Yeah, maybe we should mention as well that the idea is to make this configurable in the future, or somewhat easy to configure. So you could configure for different platforms the states and the checks you think is necessary. Today, or the first thing I think is going to be K-build parameters for at least like having arming on by default or not. Then how we will implement this is maybe another dev meeting. Yes, I mean, today there's 3 ways of configuring stuff, right? It's the K-build, we have the persistent parameters, and we also have defaults in the code. So yeah, making this more easy to use is maybe a new dev meeting topic.
Yeah, we got another question if the framework also handles low battery. And yes, that is also implemented in the current version. Yeah, I mean, we want to get all these different types of problems into the same place.
So maybe if I can ask directly.
Yeah.
So in case of a, let's say, low or critical battery, is this now handled by the new supervisor?
Yeah.
And so what is the action? So it will, I assume it will force landing.
I don't remember actually. I'm pretty sure we added it, or otherwise we should.
Yes.
Okay.
I don't think it's any difference than before, right? It's
No, I don't think so.
no.
It might be in the pre-flight check or something. I
Yeah.
don't remember.
But we will be easily able to add something like soft landing or something when it's critical low or in the future. That's the idea. So this step is only to move everything into the framework so it's easier to work with. Then next step will be to actually add features.
I could mention that one of the problems we had is to sort of maintain the API we have now, because we have there are a few logs, for instance, log variables that you can look at that this like is flying, can fly, is tumbled, I think, and we can probably maintain these. They are fairly general, but the sort of one of the things we struggled with was how much of this of the state should we expose in APIs in one way or another. I mean, we could expose the state itself, but then the other side of the API, the user of the API, must also understand what this state actually means. And the problem of exposing it is that we also lock ourselves into, it's going to be hard to change the states because the consumer of the API must also update, and then we need some complex versioning versioning principle for this. So we're not really sure where we're going to end up. My opinion is that it's probably better to keep some sort of higher level of information. For instance, is flying or is tumbled, that we can derive from the states. But I'm not sure. I don't know if anyone has any opinion about this. What would be useful?
No opinions, I guess.
No opinions.
No.
Do whatever.
Yeah,
Yeah.
is there
Yeah.
any other questions for about safety measures? What should we add? Shouldn't we add anything? I guess not.
No. Can we talk a little bit about arming, maybe?
Yeah.
Do
Yes.
it.
Yeah. So I mean, part of this is also the arming functionality, which we kind of studied a bit. Especially Kimberly has been going through all the different other flight stacks out there, and also, I mean, the naming and of is not consistent between flight stacks and stuff. But I think we want to at least implement what's generally what most other flight stack have. Like there's going to be one arming way through this Crazyflie client with a button. And then there's going to be some gestures that you could use with a joystick or a transmitter. And then there's going to be a parameter you could also set, or everything, or actually control through a parameter. So you could do this through scripting as well to trigger the arming or not. And also one aspect of this is that the disarm you can actually do whenever, and a disarm is the same as actually cutting the power to the motors, which is actually a kill switch, which is not also always evident in different flight stacks. But so it will also work a bit like a safety switch. But this is generally what we have seen is out there, and we're just going to copy it for simplicity. Any opinions on that, or sounds good?
Well, I'm wondering how the arming would work with manual control. because I think when it's autonomous, you just set a parameter to arm, and it's part of the pre-flight procedure. With manual flight, there are multiple ways how you can fly a Crazyflie or a Crazyflie bolt. So I just like see a lot of different ways how this could be implemented. I actually looked at the code quickly before the meeting, so I saw that right now there is a function to basically arm, and you can also set a parameter, I suppose, which so that gives you two options.
Exactly, and they all control the same variable. So even if you're arming from within the system, it's gonna change the arming state, as well as through a parameter. So before there was one parameter state, and there was an internal state, which were kind of separated and ORed together. But this doesn't really work. So now it's one state. So it's, and I guess in like the flapper use case, since it's not really dangerous, maybe you want it to automatically arm every time, so you don't really care about arming. But in the same way, you need the idle thrust. So when you arm, also the idle thrust is gonna kick in, which means that the motor is gonna spin up, which is kind of necessary for brushless motors.
Exactly.
Which might be needed for the flapper. So then you're going to need a arming state anyway.
So exactly, that's what you mentioned is true. And currently we decided not to use arming because for manual flight there was no, let's say, clear procedure how to do that. But for autonomous flight, it's better to arm because of the idle thrust, because then your motors spin up prior to taking off. So if the current framework will make this easier, like with the manual flight is a bit challenging in a way, because you have multiple ways how the set points can get in. It can be an external radio, which is not used much. It can be this multi-module transmitter that connects directly, and then you can have a CF client in between. And then you can also have the app, the Android app. And I think, certainly in the app, I don't recall it would be possible to arm the motors.
No. And I don't think we will implement that either. So if you want to fly with app, I would have to have a configuration which doesn't require arming.
Which I think makes sense. But that was the reason why basically we didn't use arming. So if we can streamline it such that all the options can give easy way to arm the drone, that'd be nice.
I mean, there will probably be some use cases which are going to be hard to, but we're going to cover the most common one at least. Yes, that was.
Anything to add, to ask? You can still use the chat if you want. No, doesn't seem so. We can also maybe switch on to more general support question. So if anyone has any general questions about that you want to ask to Bitcraze, Bitcraze is here.
Yes, hello. I
Hello.
have some general questions because I'm quite new to your system, and I find it really great. But I just got the shipping with a Bitcraze 2.1 thing, and I tried flying it with the help of Bitcraze radio and computer. However, well, maybe I haven't figured out yet, but the flight mode is really looks quite manual. Like you control thrust and you control other parameters with a gamepad, but I'm unable to maintain height or something, or direction of the flight. I don't know, maybe I just haven't figured out how to switch to some more managed flight mode.
I can answer it, maybe.
Yeah.
Try.
Okay.
I mean, yeah, it depends a lot what you have. I mean, the bare Crazyflie without any external positioning system, or like
Yeah, just the bare one.
Yeah, then there's no. I mean, this is just keeping the heading or the level with the IMU. So there's no position information in there. So for any like assisted flight or scripted flight, like the flow deck is a minimum. I think that yeah, I think that's probably where.
Okay,
Where yeah.
is it actually impossible to do to make some kind of this position maintaining without well, I mean using the sensors which the Crazyflie has right now, or is it's impossible?
Yes, it's basically yes. Yeah, I mean, with the IMU, with the accelerometer and gyro, it's only possible to, I mean, estimate the heading. What was it called? The level, the attitude. Yeah, exactly.
Yeah, altitude.
Yeah, exactly, attitude. So with this, you don't really know your position or where you are in the room or anything. So yeah, so manual, then a pilot is needed to do this. Yeah.
But isn't DJI Mavic somehow doing this, or maybe I mistake?
I would say all other drones that are not manual pilot have some form of system that positioning it, or I mean, optical or external, or I mean this. Yeah.
Okay.
Yeah.
Okay, that's great. Thank you.
Yes. You're welcome.